Hello everyone, this is Athreya and welcome to our channel CodeChef. Today we're going to be solving the problem Little Elephant and Bombs with the difficulty level of cakewalk. There are no such prerequisites to solve this problem, so as usual, let's get started. Here is written that the little elephant is currently on a military mission and there are n enemy buildings that are given to us. There are n enemy buildings. They're indexed from 0 to n-1, for example. Each building I has adjacent buildings. So corresponding to this index I, what will be the adjacent buildings? It will be I-1 and it will be I+1 corresponding to this index I. So whatever index we take, to the left and the right we find adjacent buildings. But corresponding to the for this building I, these two are adjacent. But what if I want to find out the adjacent buildings to the 0th index or the n-1th index? Now to the left of the 0th index there is nothing, and to the right of the n-1th index there is nothing. So the adjacent building to the 0th index is just one building which is to its right. That is the I+1th index. So I-1 does not exist. Corresponding to the last index, I+1 does not exist. The only building that exists is the I-1 to the left of it. So what it says that for any building I, suppose we have an array like this, for any building I, generally we have adjacent buildings to its left and to its right. But a special case arises when your building is the first building or the last building. That's what they're trying to say. For the first building, we have only one adjacent building, and for the last building, we have only one adjacent building. That's what they're trying to say here. That normally the adjacent buildings are I-1 and I+1. And the first and the last buildings have only one adjacent building. Now some of these buildings, they contain bombs. When a bomb explodes, it destroys itself and its adjacent buildings. This is important to note. We are given a string of length n where Si is 1 if the ith building contains a bomb, or it is 0 otherwise. We need to find out the number of buildings that remain safe. Let's look at a few sample cases. This means that there is a bomb. So 0, 1, 0 means if this explodes, it destroys itself and it destroys it as the adjacent buildings. So 0 buildings survive it. Now in the second test case for 1, 0, 0, 0, 1, what happens is we have this bomb here. This explodes and it explodes the adjacent building also. Now corresponding to the last index, only this is adjacent to this index, remember. So this explodes itself and its adjacent building. So one building survives. That's why 1 is the output. Now if there are no bombs itself, there are no ones in this array, means there are no bombs itself, all the buildings survive. So what basically we do is for every ARR of I equal to 1, we will have a Boolean array and we will say that destroyed of I equal to true, destroyed of I-1 equal to true, and destroyed of I+1 equal to true. Basically, when a bomb explodes, it destroys itself and it destroys the buildings that are adjacent to the building containing the bomb. So for every ARR I equal to 1, indicating that there is a bomb corresponding to this index at this building, we mark a Boolean array destroyed, saying destroyed of I equal to true, destroyed of I-1 equal to true, destroyed of I+1 equal to true. So then we do this. Then what we are going to do is we are going to have one more loop that counts wherever the value of destroyed equal to false. Of course, you need to handle some corner cases such as the ones that say that I-1 is not valid when your index equal to 0, or I+1 is not valid when your index equal to n-1. But these small corner cases need to be handled. But the main crux of the approach is we will traverse the array left to right and we'll keep marking in the destroyed Boolean array whether a particular building is destroyed or not. Then finally we can count the number of non-destroyed buildings and output the answer. Because when is a building destroyed? If you think about it, if ARR of I equal to 1, when that building explodes, it explodes itself and the buildings adjacent to it. For an index I-1 and I+1 are the buildings adjacent to it in the normal case. So hope this part is clear. Now let us look at the code for the approach that we have just discussed. Here, as discussed, we have a Boolean array that is destroyed, initialized to all false at the starting. Then we traverse character by character. If s of I, if the character at index I in the string s equal to 1, we know that there exists a bomb in that particular index, in that particular building. If that explodes, we know that particular index building explodes. Its adjacent buildings I plus 1 and I minus 1 also explode. So corresponding to the buildings that contain s of I equal to 1, we might destroyed of I equal to true, destroyed of I minus 1 equal to true, and destroyed of I plus 1 equal to true. We are handling the corner cases that if you're at this first index, then you do not have anything to the left of the first index, so this does not hold for the first index. Similarly, if you're at the last index, then this condition does not hold, destroyed of I plus 1 equal to true. So we are handling it that if I not equal to 0, we have I minus 1 condition equal to true. If I not equal to n minus 1, we have destroyed of I plus 1 equal to true. Just handling these two small corner cases. Then, as discussed, we have a for loop that traverses the destroyed array and it checks. If my value of destroyed at that particular index equal to false, it means that that building survived. So I'm incrementing the count corresponding to that building and outputting the total count of survived buildings at the last. So hope this part is clear. Hey guys, that was it. Thank you so much for watching this video, and if you haven't yet done this, this is a gentle reminder to hit that subscribe button. If you're interested in competitive programming and data structures, this channel is a one-stop solution for you. See you in the next video. Bye.